Hello and welcome back to the channel. It's another day and another bench test. So let's go to the ACM cabinet here, and today we're going to be working on a Mercedes MBE Detroit diesel. And let's get that over to the bench. These are MBE 4000. This here is an MCM, motor control module. This is an ACM, after treatment control module. And then here we have a CPC, which is a common powertrain controller. Generally, the CPC is the interface between all of the ECMs on the network and to us, the user. And we're going to be using a DPA5 today, again, RP1210 adapter, and we will be using it again today. Now, as I said, the CPC is generally used as an interface between other ECMs, and this would be on a Freightliner Cascadia with an MBE Mercedes engine. The problem we have today is we have a 9-pin connector on the after treatment control module, and we have a 9-pin connector on the ECM and CPC, or the MCM and CPC. I can hook to this 9-pin connector and communicate with the MCM and the CPC, but not the ACM. I can hook to the ACM, communicate with the ACM, but not these at the same time. Normally, these two communications lines, the yellow and the green, would go into these two pins. Let me show you here, these two pins on the CPC. But they're not. So I want to know why. I happened to come across a service bulletin here, and this service bulletin is for troubleshooting for this exact issue. So let's have a quick look and see if we can communicate. That would be better. If we can't, we'll do it the way we are doing it now. So let's get our wires untangled here. There we go. I'll straighten out my PF. All right, now, according to this, what we have to do is remove the ACM side connector. Make sure we have no power. Remove this connector, like so. And we're going to measure between pins 10 and 20. So let's get the scope going, fired up here. And all right. So we're going to go between pins 10 and 20. So this is 23. This is pin 20 here, according to this. This would be pin 20. And that's what it shows here. And then pin 10. Pin 10 would be fourth back. 1, 2, 3, 4. So between here and here in ohms, and we should read 120 ohms plus or minus 10. And we're getting 120.6. So that passes. Next, I'll put that back on for now. Next step is to go to the common powertrain controller and measure on jumper 3, and you see this is broken out here. That's one indication that we have an issue. Now we'll go to jump terminal 3, sorry, ST3, and measure between pins 19 and 21, which are the top and the bottom pin here. A little hard to get at. So we'll measure between this pin and the bottom pin. We should have a measurement of 120 ohms, and we're over limit. It's open circuit. There's no measurement there at all. Let's touch probes together. Yep, we're good. So the recommendation, according to the service bulletin, would be, do you have the measurement? No. Replace the CPC. So that would mean that this CPC is defective and needs to be replaced. That's why we're not connected to it. And that would explain why I have it on my bench and it's not in a vehicle. There was a problem with this. Okay, so we've determined this is bad. We're going to have to proceed without replacing it because we're not going to replace it just for the purposes of demonstration videos. Take the ACM out of the picture here. We're not going to be using it. Put it away, and then we can do some tests here. Now we'll do the same tests as we did with Cummins. We will lost a connection here. We will hook up a coolant temperature sensor to the ECM and see if we can read it in the software. All right, so first thing we have to do is figure out where the connections go. As you can see here, engine coolant temperature sensor is 110 and the signal is 53 on the 120 pin connector, and that'd be this one here. All right, so let's get a thermistor and some jumpers. Okay, here's a thermistor, and again we're going to be using a 3K thermistor. And a jumper for each of the pins that we're going to connect to. Now, a thermistor, 3K thermistor, it's 3,000 ohms measured across the two pins of the thermistor at, I believe it's 20 degrees Celsius. Because the thermistor changes value as the temperature goes up and down. Okay, so let's fire up the microscope here. All right. And the first thing we're going to do is locate pin 55. Pin 55. Pin 1 is the first pin on the left here, right here. That'd be pin 1. So let's go to pin 55. Let me just do a little bit of counting here. 48, 49, 50, 51, 52, 53, 54, 55. Okay. And if we count on, just to make, to confirm, 56, 57, 58, 59, so 55, 56, 57, 58, 59, 60. So no, we're not on the right one. One pin over. There we go. Let's just double count. 1, 2, 3, 4, 17, 18, 19, 20. So there we go. All right. We need a jumper for here. Just jumper back. Hook up our thermistor. Cycle the ECM off and on. We're hooked to power, we're hooked to ground. Now let's go and have a look at the software. Okay, zoomed in a bit here. Now the first thing we're going to do is check for DPA5 Pro, which we have. Multi-application on USB ID 2. And Detroit Diesel Mercedes, which is what we're hooked to on the bench. So let's go ahead and connect. So the first thing it does is pull up the VIN. Now that's good, nice and quick. Now it's going to check for the data plate, to read the data plate, and it's going to query and see which ECMs are connected and if ECMs are missing. And so it's connected to a chassis powertrain module, connected to the motor control module, and the ACM is not connected, and there comes our parameters. Now if you look here, we put the sensor on. Look at that. Now we're reading. We were reading before a bad value of, I think it was 215 or 230 degrees C, which is an error. So let me go over and put my finger on the thermistor, warm it up a bit, and see if the temperature changes. And yes, it did. And now it's coming back down. So there you go. The coolant temperature sensor circuit in the ECM is okay. If we were not getting a coolant temperature signal in the vehicle, the problem would be the sensor or the harness. So again, another practical application of PFD-Tool using a Mercedes MBE. Again, we can go into the tests. We can run a number of tests, DPF regen, dot face plug cleaning, fast vital warm-up, DEF coolant valve test, DPF ash accumulator reset, SCR and ACM replacement, SCR accumulation reset. And there are more tests here. We are going to put them in as we get them perfected. So the number of OEM tests that will be available will be increasing. And again, there's never any charge or fee for updates, and support is always free. So thanks for stopping by, and I'll catch you on the next one.